All right, so let's do the second half of this superposition problem. So now we shorted our voltage source here, and we need to solve for these voltages. Hopefully right off the bat you recognize that VZ2 is just a short to ground. So VZ2 is going to be quite simply just 0 volts. And another one that it might not be trivial to recognize that there's another one that we can find very quickly. But VW2, we know the current I1 has to flow in this branch so that it can flow in the current source, right? And so if that's the case, we already know the current flowing through this R1, and we know R1, so we can really quickly just find VW2, right? It's going to be 0 volts here, basically 0 volts minus VW2 over R1 is going to give me the current that flows in that current source, which is 10 milliamps. All right, so I can just take basically negative, let me move this up a little further even, minus 10 milliamps divided by R1, which is 5K, or sorry, multiplied by 5K. That's going to give me VW2, and that looks like it's going to come out to negative 50 volts. Okay, so let's box that. So we've got VW2, we've got VZ2, and now we need to find VX2 and VY2. And so maybe it's not obvious right now, but if I redraw this circuit, let me redraw it, I think that it will become obvious that I have a current divider here. Maybe it is obvious. I basically have a current source feeding a node that has, some resistance here and some resistance here, which is exactly what we had when we looked at current dividers. So if I redraw the circuit, I've got basically a resistor and a current source, and then I've got my R2, and then I've got my R3 and my R4 in series. And so this is basically the exact same circuit that I'm looking at here, right? Where R3 is 10K. Oops, I don't know what happened there. R3 is 10K, R4 is 2K. My R1 is obviously 5K, and then my R2 is 8K, and my current is 10 milliamps. And so if I want to find, what am I looking for? Basically, I'm looking for this voltage, which is VX2, and I'm looking for this voltage here, which is VY2. Well, if I can find the current through this branch, then I can determine those voltages. So let's go ahead and use the current divider equation to first determine this current. I'll call it I1, and we'll call this one I2. And of course, we know that 10 milliamps is equal to I1 plus I2 from KCL at this node, right? So let's go ahead and use the current divider equation to determine I1. I'm going to say that I1 is equal to 10 milliamps, right? The current flowing into the node, multiplied by, so I want to find the current through the 8K, so I need to use the other two resistors in the numerator, which is going to be 12K, right? 2K plus 10K, divided by the sum of my resistors, which is going to be 12K plus 8K, or 20K. And so that comes out to 0.6 times 10 milliamps, which is just going to give me 6 milliamps, right? So I have 6 milliamps. And then I know that I2 has to be 10 milliamps minus 6 milliamps, so that's going to be 4 milliamps. So now I just found my currents, and now it's trivial to find my voltages, right? So right now I can very quickly find VX2, which is going to be 8K, basically I times R, 8K times I1, and that's going to give me 48 volts. And I can find VY2, which is just going to be 2K multiplied by my current through that loop, and that's just going to give me 8 volts, okay? And so I've got VX2, I've got VY2. Ooh, wow, that is not what I wanted to do. Okay, that's pretty sloppy. Let me try and move some of this stuff. Okay, that's much better. All right, so we have all of our voltages. Now we just need to add them to get our final results. So it's looking like I don't have that much room, so let me try and just use another color to distinguish. So VX1 plus VX2 is equal to VX And VX1 was 9.6 and VX2 is 48. So that comes out to 57.6 volts. VY1 plus VY2 is 8 plus 21.6, which comes out to 29.6 volts. VZ1 plus VZ2, obviously we have 0 plus 24, so that's just going to be 24 volts, which from the very original circuit, you should be able to determine right off the bat that this would be 24 volts. And then lastly, I guess I didn't do VW, but again, right off the bat, nothing changes in this circuit, so you should be able to determine that this was negative 50 right off the bat, even without superposition. And so that one's, I keep going way too far. VW is negative 50 volts, and those are the answers for this problem. All right, if you want to try another method and test yourself, or if you just want to try and work this one out, those are the voltages. And I'm going to go ahead and end this video, and then we'll do one more example problem before we end this module.